Hey students, this is lesson 1-1. This is the first lesson. Not only will you be learning how to watch videos and take notes with that video, but also learning a little bit of something. And here's what we're going to do. Oh, shoot. Oh, man. Oh, well. So here's the objectives of this lesson. We are going to learn how to represent and interpret increasing and decreasing linear relationships in words, tables, graphs, and equations. That's the one we're going to focus on in this lesson. And then we're also going to learn how to classify relationships as direct variations, linear relationships that are not direct variations, or nonlinear. All right, I'm going to go to this problem here. And Michaela, one weekend, she delivered pamphlets explaining her Newtown's recycling program. Here's where I am. On Saturday, she delivered 350 pamphlets. And on Sunday, she delivered 150 more pamphlets an hour. Now, to represent this situation, we actually have a couple things going on here. First of all, we want to just take a look at how many she delivered on Sunday alone. That'll be this place here, where so S stands for Sunday only. And then we also want to know how many total deliveries she made, including Saturday and Sunday, and that'll be this spot, T. All right, so let's do S first, Sunday deliveries. On Sunday, if we don't include the one she delivered on Saturday, she started with 0 on Sunday, that's right here, and then every hour she delivered 150. So after 1 hour, she delivered 150. After 2 hours, 300. And we can keep adding 150 to every value here to fill in this table. Now that's an increasing linear relationship. It's linear because we keep going up by 150. And it's increasing because the numbers keep going up. Now if we look at the total number of deliveries, including the ones on Saturday, we start at 350 on Saturday, and then on Sunday, every hour she adds another 150 to that. So that again is a linear relationship because we're adding the same amount every time. And then after 2 hours, she'll add another 150, which will make it 650, then 800, then 950, then 1100, and then 1250 total. Okay, so that's also a linear relationship because again it goes up by the same amount every time, and it's also increasing because we're going up by 150 every time. Now I'm going to skip down to the bottom here where we're going to write an equation for those two relationships, so we can kind of get used to that. So first thing we're going to do is write an equation for Sunday deliveries. So that's number 3 here. On Sunday, so we're going to use S for the number delivered on Sunday. So this S actually means a lot more than that. It means the number delivered on Sunday, so not including Saturday. Now on Sunday she just delivered 150 every hour. Well, we could keep adding 150 for every hour, or we can just multiply 150 times the number of hours. Now you may in the past have used a dot to represent multiplication. But in algebra, we're going to skip that dot and just know that when there is no dot, it means multiplications. So if we take 150 times the number of hours, we will get the number delivered. Okay. Now the second part, the total deliveries, this one here, she started with 350 and then added 150 every hour. So we're going to use T for total deliveries for number 4. Now, since she also has 150 for every hour, we can again multiply 150 times the number of hours. But we need to add on the number of delivered on Saturday, which is 350. Okay? So this is an example of an increasing linear relationship. All right, let's look at one where we have a decreasing linear relationship. And that would be number part D here. It says, suppose Michaela started with 1,000 pamphlets. On Saturday, she delivered 350 of them. On Sunday, she delivered the remaining pamphlets at a constant rate of 150 an hour. Number 1 says, how many pamphlets did Michaela have left to deliver when she began work on Sunday. So she had 1,000 total that she needed to deliver, and on Saturday she delivered 350 of those. So the number she has left is just 1,000 minus 350, which is 650 pamphlets to go. Okay? On the next page, now remember, if you kind of get behind while I'm doing these videos, you can just press pause and fill in whatever you need to fill in, and then just start it again. So number 2 says, copy and complete the table which show the number of pamphlets that Michaela has left to deliver after each hour of work on Sunday. So after 0 hours worked on Sunday, remember she had already delivered 350 on Saturday, so she had 650 remaining. Every hour she delivers 150, so that means she has 150 less to deliver. So I need to subtract each hour 150 from that amount. That's going to give me 500 left to deliver after 1 hour, 350 after 2 hours, 200 after 3 hours, and 50 after 4 hours. Okay, now this equation is going to be a little bit different. Instead of going up by 150 every hour, we're actually going down by 150 every hour. So if I use a negative to represent we're going down by 150, I can take negative 150 times the number of hours to get the total I went down. But I have to start at 650 again, because that's where I started, so I need to add 650 to that, and that will be the amount remaining, which is R. Now some of you were thinking maybe you could just start at 650 and then subtract 150 times the number of hours. That also would work. Okay? And if we were to make a graph for that, let's just take a quick look at how the graphs of these two situations are different. Now this is a decreasing linear relationship because we are, again, changing by the same amount. It's dropping 150 every time, but the numbers are going down. And if I graph this situation, I would start at 0 hours, 650, 1 hour, 500, 2 hours, 350, 3 hours, 200, 4 hours, 50, and so on. And notice that the dots are heading in the down direction this time. And they're going to keep going down as long as she's delivering pamphlets. All right. Now if we go back, I'm going to go back a page here. If I go back to my other situation and graph that, so I'm at number develop and understand part B. Remember in this situation, this for her Sunday deliveries, she started at 0 and went up by 150 every hour. So after 1 hour it's at 150, after 2 hours it's at 300, then 450, then 600, then 750, and so on. And notice that this one is going in an up direction. Okay, that's an example of an increasing linear relationship. All right, so just a quick review. An example of a linear relationship in general just means that that it's changing by the same amount every time. An increasing linear relationship is like these two examples where the numbers keep going up and the graph is headed towards the top of the graph as you move to the right. And a decreasing linear relationship is like this example where in the tables the numbers keep getting lower but by the same amount, and the graph moves in a down direction as you head to the right. It goes down. All right, that's it for this video. We'll do the other problems in class and learn more about direct variation.